We've got 9.4, solve polynomial functions, or sorry, polynomial equations. Let's see, in factored form. So I think y'all did some foiling and stuff like that before. So that was where you had like the two parentheses with things in them and you were multiplying the stuff in them. These will already be in that form, but we're going to actually be solving them, basically solving for the variable. It's way easier than that stuff in my opinion. So we have the zero product property, which says let A and B be real numbers. Oh, okay. What is happening? There we go. If A times B equals 0, then A is equal to 0 or B is equal to 0. Now, obviously, both can be true, but typically that's not going to happen. But all that's saying is that anything multiplied by 0 is equal to 0. And so that's true of if we have just numbers or if we end up with having these factors, right? Like if you remember the form of what FOIL looks like, essentially we'll have that. It'll be equal to 0, and we're going to be solving for it. And we'll also have some stuff with the greatest common factor. Did y'all talk about that at all?
Yeah, we
You're
went
okay.
over it a little bit
Okay.
after the quiz.
Okay. So the greatest common factor is essentially something that we can take out of both pieces of the thing to like factor something out. I'm sure she's going to be back.
Oh my god.
So basically this is the largest thing. I try to put this in like my own terms as much as possible. The largest number or term, because it can have variables in it that both or that all pieces have in common. So with that, what I mean is sometimes with what we're doing, it'll pretty much be what both pieces have in common or maybe what all three pieces have in common, up to like 4. But we could have something much bigger. Just as far as this stuff goes, it's going to probably have between 2 and 4 terms that we may be factoring something out of. There's also some stuff that's kind of like physics-y type problems in here, but we're probably not going to hit any of that. We may briefly go back to it later, but I'm going to just skip that stuff for now because we need to learn how to do all this other stuff. So we're just going to jump into some problems here as far as solving the equation. So these say y plus 9 times y minus 1 equals 0. So the temptation of a lot of people, because you've already learned to FOIL, is that they start FOILing these first two things. Well, we don't want to do that, okay? This is just like this zero product property applies to things when it's just numbers or to these things when they're terms like this. So this means that either y plus 9 equals 0 or y minus 1 equals 0. So I'm going to set this up. Turn this off before it keeps trying to solve things for me. So I'm going to have y plus 9 equals 0 or y minus 1 equals 0. And now I solve these down individually. Okay, some people write or between them. I don't. Obviously, y can't be two different things at the same time. We understand that, but I just normally write them. The book will write your final answer as whatever, comma, whatever, are like the two answers. So how do I get y by itself? Yep, so in this one, I'm going to subtract 9. So this is going to be y equals negative 9. Over here, I would need to add the 1, so this would be y equals 1. So these two things would be my answers here. I mean, honestly, this stuff is made to be easier. Obviously, this is the stepping stone into the, greatest common factor and stuff with this. But this stuff should be easier than some of what we've been doing. It should be a nice little break for a little bit of what we've been doing. So number 6, c plus 6 times c plus 8 equals 0. So we take each piece and set it equal to 0. And I'm going to say from now until the rest of your math career, you are going to hear that. I literally was just doing this with them in calculus 30 minutes ago. Okay, they were given something and they had to set each piece equal to 0. Even as far as physics and other sciences, you'll have stuff like this too. We're going to have something and we're going to set each piece equal to 0 and solve. So this will be c plus 6 equals 0. What is happening? This is like glitching. And then c plus 8 equals 0. And so obviously these are nice because it's not like things that I'm like adding and subtracting numbers together. I'm literally just moving them over. And don't think that they're just always going to be like one variable. Like we're going to get to ones that have a number in front of the variable. But it's just solving like 1 and 2 step equations that we did back in, I don't even know what chapter that was, 4, like a long time ago. So subtract 6, so c equals negative 6, or over here, subtract 8, c equals negative 8. Let's see, 8 g minus 1/8 times g plus 18 equals 0. So, what do I do first? Yep. Separate it and set it equal to 0. So g minus 1/8 equals 0. G plus 18 equals 0. So what do I do with the one on the left?
You add the 1/8.
Yep, add it. So g equals 1/8. And then what about the one on the right?
G equals negative 18.
Yep, subtract. So g equals negative 18. So those ones aren't too bad, right? We're just moving it by adding and subtracting. So those are kind of just like our basic one-step equations. But we're also going to have some that end up kind of being 2-step equations where we're multiplying or dividing by whatever's in front of our variable. And so that would be something like number 10. So I've got 2n minus 14 times 3n plus 9 equals 0. And the other thing I'm going to say here is this property only works when it's equal to 0. Not so much now, but like later in math, I have students oftentimes that they'll have this like equal to 3 and they start setting each piece equal to 3. It does not work that way. You have to have it in factored form equal to 0 for us to use this. That's why it's called the zero product property. Okay, sometimes you'll also hear me say the zero factor property. It's the same thing. I just use the words interchangeably. This book just calls it zero product property. All right, so set each piece equal to 0. So I've got 2n minus 14 equals 0, and I've got 3n plus 9 equals 0. So these are our little 2-step equations. So I add the 14 over. So 2n equals 14. Then I divide by 2. And so then n equals 7. And notice, I'm working 1 all the way down so that I don't get lost in what I'm doing. Some people start trying to do like the steps of each one. Like I would work one whole problem down and then work the other one down so that you're not getting confused about what's going on. So then over here, we're going to subtract the 9. So 3n equals negative 9. Divide by positive 3. Negative divided by positive is negative. So this is negative 3. 9 divided by 3 is 3. So this is 7 or negative 3. Let's see. 12. 3x plus 1 times x plus 6 equals 0. So let's do this. I want y'all to try this one on your own, because I want to save the last one of these ones to do together. So take a minute and just do this one on your own and see how you do with it. we have an answer? What do we get? Did everybody agree?
Yeah.
Good. Yeah, so sometimes one of them will have, multiple steps and one of them will just have one, and that's fine. And so, anyways, just be aware of that, but it seems like we've got that. Number 14, 8z minus 6 times 12z plus 14 equals 0. So, again, we're going to take each piece, set it equal to 0. So I've got 8z minus 6 equals 0. 12z plus 14 equals 0. So what do I do with the one on the left?
Add the 6.
Yeah.
Add the 6. So I have 8z equals positive 6. Now what?
You divide by 8.
So I have z equals 6 over 8. Can I leave it like that?
No, you
No,
can reduce
3
it.
over 4.
Yep, I need to reduce it to 3 over 4. All right, and then the one on the right, what do I do first?
Subtract 14.
Subtract 14, so 12z equals negative 14. Then what?
Divide by 12.
Divide by 12. So that would be negative 14 over 12. And then what do I get when I reduce it?
Negative 7 over 6.
Yep, negative 7 over 6. Now, if you can go ahead and reduce 14 over 12, obviously you don't necessarily have to write these intermediate, this step here. You don't really have to write that. You can go straight to the answer if you can reduce it in your head. Just know the more work you show, the better, obviously, your partial credit's going to be.
Could you also write it as a mixed number?
No, I want them left improper.
Okay.
Same thing we've been doing all year. The book leaves them improper as well, just for the record. All right, any questions on that? All right, we'll be back to this stuff in just a little bit. It'll look a little different, but now we're getting into factoring out the greatest common, now they say monomial factor. Basically, we're just taking out the biggest thing from, I think they're all 2, from the 2 numbers, and it may have a variable in it. It may just be a number. It's just, when they're saying monomial, it just means one term. Okay, so number 18, 6x squared minus 15y. So I'm looking at this and I want to know, okay, I clearly can see these don't have any variables in common. I know that 6 doesn't go into 15, but is there anything that both of those numbers do have in common?
They're an x related to 3. I forget if it's like
Okay.
it,
Yeah, well, it would be 3. So both of them are something multiplied by 3 that gives me that number, right? We can see that?
Yeah.
Okay. So 3 is going to be the thing that I'm taking out. So this is going to be 3 times, this is kind of like reverse distributing. Essentially, when we're factoring out a term or finding the greatest common factor, we're factoring out basically what we would do to undo a distributive property problem. So in this case, I'm taking out a 3. So I'm saying, okay, 3 times what equals 6? 2. So there's going to be a 2. I obviously didn't touch the variable, so 2x squared. And then I took out a positive 3, so this is going to keep the same sign. 3 times what gives me 15? 5, and obviously, like I said, it's going to be negative, and we keep the variable because nothing came out. So this is all that we would do with this.
Easy work.
So ultimately what this is leading us to, we're going to do several more of these, but is that the 2 things that we've done so far, we're going to end up in the next set of problems, we're going to smush that together. We're going to factor something out, then we're going to solve. Okay, so right now we're just factoring, but we're going to move into that in just a little bit. There's only a few of these problems. So 25d raised to the 6th power plus 2d to the 5th power. So this one might be a little bit more obvious. Okay, obviously 5 and 2 don't have anything in common, right? 2 doesn't go into 5. There's nothing that, is a factor of both of those. But what is in common between these 2? D. So I know it's going to be D, but I need to determine now how many of them I can take out. So I can take out the lowest powered term one. Okay, so notice this one's raised to the 6th, this one's raised to the 5th. So I can take out 5 of them. Okay, so this is going to be d to the 5th times 5. If I take out 5 of them, that means that I'm subtracting 5 from here, so I'm left with 1 of them. And then over here, plus 2, I took out d to the 5th, so that would just become 1 now. Now, the other thing with this, we can always check these by distributing it back. So you can cover up this, and we can check it by distributing here. So d to the 5th times 5d would be 5. And then that would be d to the 5 plus 1, if you remember our rules of exponents that we did a couple weeks before spring break, which would end up being d to the 6th. And then plus 2d to the 5th. Now, I go back and I say, okay, that is what I started with, so I know that this factored form, where I factored something out, is correct. Okay, so you can always go back and check to make sure that what you factored out actually makes sense. And that's really important because you don't want to accidentally factor the wrong thing out and then you're solving it and then all of a sudden your math is like, because you factored out the wrong thing. All right, 22. 9m to the 7th minus 3m squared. So what do we think about this one?
They both can be multiplied by 3.
Okay, so I'm going to take a 3 out because both things have a 3. Is there anything else? Yep, m, and then how many m's can I take out?
2.
Yep, 2, so this is going to be 3m squared. So if I take out a 3m squared, what am I left with on this 9m to the 7th? I took out a 3. Yep, 3, and then I've got to take away 2 from that exponent, so this would be m to the 5th. And then minus, I took out a 3m squared, so what happens?
It's just
1, okay? Because I've got to have something to multiply this back by, okay? So I can check this. Again, I can cover up and check. So if I distribute, 3 times 3 is 9, so that would be 9. M squared times m to the 5th would be m to the 2 plus 5, which is 7. And then over here, minus 3m squared. But the reason I asked is because a lot of people do tend to do what several of y'all said, where you're like, oh, it's 0. No, when we factor something out, that's multiplication, okay? And so that means that there has to be a 1 left in its place, okay? So then we've checked that one. It matches because this would have become 7, and so I'm good. Let's see. 24. 12a to the 5th plus 8a. What can I take out of this one?
4.
A 4. What else? An A. And how many A's? Yep, just 1 because this one has an exponent, so whatever the lowest powered one is, that's what I can take out. And so 4a times what gives me 12a to the 5th?
3.
3 what?
Oh, 3A.
To the 4th. Yep, so we always subtract 1, or subtract whatever this exponent is. So in this case it was 1, so that would give me 4. And then what about when I take out a 4a from 8a?
2A.
Just 2. So this is basically another way to think about this if you feel like you're having a hard time like getting this concept. Another way that you can think about this is saying each of these terms and dividing it by these things. So I could do 12a to the 5th over 4a. And when I do that, I can say, okay, well, I just really canceled it. 4 goes into 12 3 times, and then this would be a to the 5 minus 1 from my rules of exponents, and so I would get 3a to the 4th. Okay, so that's another way that we can do this and get the same end result, or the 8a. 8a over 4a. Okay, a's cancel. 4 goes into 8 2 times, and so that would be 2. Okay, so that's another way you can think about it if you feel like you're having a hard time with it as it is. I know it's kind of a new and different concept, so it can be a little bit confusing. So now what's going to happen is it says to solve the equation. So it's going to give you something that looks like this to start with. We're going to have to factor it out, and then we're going to solve. So this is where we're putting together the two things in this section so far. So 28. 5w squared minus 5w equals 0. What else? Yep, so this is going to be a 5w, and what's left with 5w squared when I take out 5w? Nope. Yep, just a w. So 5w squared divided by 5w would just be w. And then minus 5w divided by 5w, what would I be left with? Negative 1. Yep, minus 1. Now, don't forget on these ones that have the equal to 0, make sure you don't forget that part. So now we have factored out the greatest common factor. Okay? So now I can set each piece equal to 0. So I will have 5w equals 0, and I'll have w minus 1 equals 0. Now, obviously this one's a little bit different because this is just 5w. It's not plus or minus anything. So how do I get w by itself here? Divide. So w equals 0 divided by 5 is?
-5.
0 divided by 5 is?
0.
0. And then over here, how do I get w by itself?
You add the 1.
So I have w equals 1. So those are my two answers there. She doesn't come back soon. She's going to miss the entire class. All right, 30. 2x squared plus 15x equals 0. So what can I take out of this one? An x. Is there anything else I can take out? Sometimes I'm just asking you to see if you're paying attention.
No.
No, I can't. Okay, 2 and 15 don't have anything in common. So what do I get when I take out an x from 2x squared? 2x. Plus, what do I get when I take an x out of 15x? 15. So now I set each piece equal to 0. When I do that, I have an x that's already by itself is equal to 0. So that's when I go, yay, I don't have to do anything else with that one. And then the other one, 2x plus 15 equals 0. So I'm going to subtract the 15. So 2x equals negative 15. Divide by 2. X equals negative 15 over 2. So I have x equals 0, and then also x equals negative 15 over 2. All right, I want you to try this next one by yourself. So you're going to have to factor this stuff out, and then you're going to solve it, and we're going to see how we're doing with this, because then the next few are a little bit different than these. So 32 is negative 32y squared minus 24y equals 0. The only other thing I'll point out with this one, because we haven't had this happen yet, is that if both numbers are negative, even if they're not, we can't do this, but if both numbers are negative, we're also going to be taking out a negative. Okay, that would be something that's like considered a common thing between them. Okay, so make sure you take out a negative when you do this, because these are both negative numbers. All right, what was our factored form? What is our factored form? So not the final answer, but what's the first thing you did when you factored something out? What'd we get?
8y, like 8y parentheses negative 4y minus 3.
Okay, so you didn't listen to me. Anybody else? What did I say when I put this problem up and then I said, oh, we haven't had this yet. If this is the case,
You have to bring out a negative.
yes, you got to also take out a negative. So your numbers are right, but you didn't take out the negative. So this should be down here. I'm not giving you the answer. This should be where you were at. Okay, so you should have had negative 8y and then times 4y plus 3 equals 0. Okay, so if you didn't have that, fix it and then go back and finish solving it out. So take him. Oh, I just hit the wrong button. Okay, well, I can't move it. I hit the video button on this instead of the camera button, which like freezes it, and it doesn't have a card in it, so it says the memory's full. I'm like, well, yeah, because there's nothing there. Anyways, and then it takes forever to come back to life, so. All right, so what do we get for our final answer?
Y equals 0, y equals negative 3.
Okay, does everybody agree? Disagree? Have something else? Do you even know what she said?
0 and then negative 3/4.
Okay. Yes. So we factored out the negative 8y, which gave us inside the parentheses 4y plus 3. Set each piece equal to 0. So dividing by negative 8, that gave us 0. And then subtract 3. Divide by 4 gives us negative 3/4 for the one on the right. Any questions on that one? All right. A couple more here with these that are just a little bit different in their setup. So 34, we've got 6h squared equals 3h. Okay, so this one is obviously different in that it's not everything on one side equal to 0, right? So this is why I said earlier you've got to get everything equal to 0 before we start doing anything. So the first thing I need to do is I'm going to move everything. It doesn't matter if you move it to the right or the left, but we typically end up with 0 on the right. So I'm going to move 3h to the left. How do I do that? Subtract it, yep. So I've got 6h squared minus 3h equals 0. Now what?
You divide by, you take out the 2h.
Not 2, but I can take out an h. Yeah, 3. Because 3 would go into 6, but 2 doesn't go into 3. So I take out a 3, and I take out one single h because I have h squared and I have h. So when I take out a 3h from 6h squared, what do I get?
2h.
Yep, 2h. And then, yep, 3h divided by, or take out a 3h gives you 1. So that would be minus 1 there. And then we just set each piece equal to 0. So 3h equals 0. And then 2h minus 1 equals 0. So I've got h equals 0. And then I've got 2h equals, add the 1. So 1, and then divide by 2, so h equals 1/2. So I have h equals 0 or h equals 1/2. $36. Negative 42 z squared equals 14z. So what am I going to have to do with this one? Subtract 14z. Now, I could also move the negative 42z squared to the right instead, okay? It will end up giving me the same final answer, okay? If I move the 14z to the left, both numbers are going to be negative. If I move the negative 42z squared to the right, they're both going to be positive. But our final answer will be the same. I can prove that to you in a minute, but for right now, we're going to move to the left just like we normally would. And so this would be negative 42z squared minus 14z equals 0. What can I take out of these things then?
7.
Z.
Yep, and they're both negative, so what should I do?
Bring out a negative.
Take out a negative, so negative 7z, and then times, what happens when I take out a negative 7z from negative 42z squared?
It's 6.
Yep, positive 6z. And then what about when I take out a negative 7z from negative 14z?
Okay, 2.
Yep. And it would be plus 2 equals 0. So then set each piece equal to 0. So I've got negative 7. Whoa, that's not a 7. Z equals 0. And then I've got 6z plus 2 equals 0. So z equals 0. Over here, subtract 2. 6z equals negative 2. Divide z equals negative 2 over 3, which is equal to, nope, I did that wrong, negative 2 over 6. I was trying to reduce it in my head, and then I only reduced half of it. So then z equals negative 1 over 3. Now, I'm going to show you that if I moved it to the right so that I had positive numbers instead of negative numbers, that I would get the exact same thing. So instead, if I moved this to the right, I would have 0 equals 42z squared plus 14z. I would then factor out a 7z, which would give me 6z plus 2. Set each piece equal to 0, so I would have 0 equals 7z and 0 equals 6z plus 2. And even if you do it this way, you can still put the 0 on the right. It doesn't matter where it is. That is a really large plus sign. What is happening? So then over here, divide by 7. Z equals 0, which is the same thing I had there. Notice it was a negative 7, but since it's equal to 0, when we divide, I end up with that. And then over here, subtract 2. Negative 2 equals 6z. Divide by 6. That would end up giving me negative 1/3 equals z. So either way that I move it, I will get the same answer, and that's always true, regardless if it's making one of them positive, one of them negative, both of them the same, whatever. That will always be true no matter which way you move it. We just typically do move it right to left so that our 0 is on the right-hand side. But any questions about that? Okay. Let's do one more of these. I want y'all to try it by yourself. So 38, negative 12p squared equals negative 30p. So again, it doesn't matter which way you move it, totally up to you. All right, do we have an answer? What do we get?
P equals 0, P equals 5 over 2.
Good. Yep. So I moved the negative 30p to the left, so I added it over. Again, you could have taken the negative 12p squared to the right. You will get the same final answer. I then factored out a positive 6p. I could have also factored out a negative 6p, okay? But I think that probably is getting a little bit more confusing for you, so I would recommend you probably just take out the positive one for now. But like I said, if you had factored out the negative 6p instead, you would have ended up with the same final answer the way that everything works out. So 6p equals 0, negative 2p plus 5 equals 0. So on the left one, p equals 0. On the right, once we move everything around, we end up with p equals positive 5 over 2. Any questions on that? All right, one more thing. This is not a solve. This is just a factor out problem, but it's just one that's a little bit more involved that I want you to see. Is that if we have something like this, so 20x squared y squared minus 4xy. This obviously has more terms to it, but I do the exact same thing. I'm taking out the biggest thing that's out of both pieces that I can have. And so the biggest number that can come out is what? 4, right? Because if I do that, I can take a 4 out of 4 and I can take a 4 out of 20. So I'm going to take out a 4. What about the variables? What can I take out? An x and a y, because both of them have an x and both of them have a y. If I take out 4xy, what am I left with in this first one? 5xy. If I take 4xy out of this negative 4xy, what am I left with? Yep, negative 1. And then really quick, just because I see one more thing that I want to make sure that we are aware of here. And this will be the last one, I promise. So if I have something like this, which is negative 2g to the 4th plus 14g squared plus 6g, okay? This one has 3 terms, okay? So I'm looking for something that occurs in all 3 of these pieces. So there's a g in all of them. So again, I take out the lowest powered one, so I know I'm going to take out just one of them. What else can I take out? 2. A 2, right? That's the biggest, or that's the smallest number, right, that I can take out of hold on, let me rephrase. That's the biggest number I can take out of everything because 2 is the smallest number. So I'm going to take out a 2. So that would leave me with negative, subtract 1 from here, so that would be g cubed. Plus, take out a 2, that would be 7. Take out a g, so that would leave me with g. And then over here, 6 divided by 2 is 3. G divided by g is just 1. And so this would be 2g times negative g cubed plus 7g plus 3. So we can take it out of 2 things. We can take it out of 3 things. We can take it out of 4 things. We can take it out of however many, as long as every single one of those things has that number, variable, whatever in it, we can take it out. Okay? All right. I know that was kind of a lot, so you don't have as much time to work, unfortunately, as we sometimes do, but that'll be what it's going to be. So let's see. Problems. Let's do 5. 9. 13. 19. 21, 27, 31, 33, 37, and then the ones that we just were doing, 41 and 45. So make sure you pay attention to the instructions if it's asking you to actually solve. Pretty good hint as to if they're asking you to solve, aside from reading the instructions, is if it's equal to something or not. If it's not equal, notice these ones weren't equal to anything. We didn't solve them. Okay, one you could not have solved this one. You don't know how to solve that yet. But anyways, if it's equal to something, you got to solve. If it's not equal to something, you don't have to solve. You just have to factor it out. So just make sure you pay attention to the instructions on that.